Can you just help me with where you guys are from? Everybody from Bangalore or Bangalore? Oh, Bangladesh. Awesome. What about you, man? Where are you from? Denmark. Delhi. Oh wow, that's really great. We have a good cross section today of Joomla and Asia in general. So today I'm going to be talking about using the Joomla framework, not the Joomla CMS, and how we have used the Joomla framework and Raspberry Pi to build some things around the Internet of Things. So have you heard about the Internet of Things in general? Have you heard about the Internet of Things? Yeah. So IoT is a really big space that's heating up, and it's about getting a lot of devices online. So we already have a lot of people online. Now it's about getting devices connected and controlling them and doing some exciting things with them in the cloud. So today it's going to be Joomla and Raspberry Pi and how it can help the Internet of Things. So just a quick introduction. So I'm Parth Lawate. I'm working with the Joomla marketing team, and I'm a strategic marketing manager for the Joomla team. Other than that, my day job is I'm a CEO at Tech Joomla and TechD Technologies. Those are my Twitter handles. You can follow me. And that's some things I do and like. I do a lot of trekking. I like gardening, and I also do a little bit of Joomla and PHP and stuff like that. So hi everybody. So this is TechD Web Solutions. So we got renamed to TechD Technologies just a year back, and we have been invested into Joomla for more than 9 years now. So we've been working with Joomla since the Mambo days. We also do a lot of things with HTML5 and IoT and custom applications, e-learning, a lot of things around that. Tech Joomla is our specific company that is focused on Joomla-based consulting and product development. So a lot of our products are branded Tech Joomla, and we sell a lot of these products online. Some of our notable open source contributions, we have contributed the REST API to the Joomla CMS. So it's basically not part of the CMS, but you can use the components that we have to build your own mobile applications with Joomla or do stuff like what we have done using Joomla. Then the other thing is the payments API. So 2 world conferences back, we open sourced and released the common payments API for Joomla. So this basically lets you quickly build e-commerce products with Joomla. So we will give you a complete checkout, and we support something like 50 different payment plugins from all over the world. So if you want to build something in e-commerce with Joomla and you use this, you're going to cut down on your coding time in a big way. So all right, so let's start. So what is this LCMS thing? So so is it a fork of Joomla? Are we going to get a fork? So we are not really talking about content management here. What we are talking about is, oh yeah, so you can't build a website with the LCMS, just to make it clear. So basically LCMS stands for Lighting Control Management System. And what does it do? So this was, just to give you a bit of history, this is, we have done a couple of projects around this, and we have deployed it on 2 big industrial sites in the US. And this is what it does. It lets you do device management. You can do group devices together. You can do manufacturing management. You can do user management. So let me give you a basic idea. So let's say you are, you look after the maintenance of this hotel building. How many lights do you think this hotel has? Can you imagine across the rooms, across all the conference spaces? Rough number? 10,000, 20,000, maybe more. Can you imagine just checking what warranties you have on the lighting? Because in a space like this, you can't afford to have your lights suddenly go off. You need to know when they are going to expire. So everything else is pretty cool, but just manufacturing management and knowing which light has been manufactured by whom, and just knowing when the warranties are going to expire itself is a great value add. And here we are going to talk about actually controlling lights. So when I say device, right now I'm going to mainly be talking about lights. But the way this system has been built, basically we can control any type of device, and it's pretty cool. I'll show you the way it works. So first thing, why do you need a LCMS? So basically you can do control and automation of lighting. You can do intelligent scheduling. So you can say that some lights need to run on sensors, some lights need to just run on timing. So maybe it starts at 7 p.m., turns off at 11 p.m. You want to do grouping. So let's say you want to do group all the restroom lights together, or you want to say floor 1, floor 2, floor 3. So you can group them together. And it will also help you maximize energy savings, because now you're actually monitoring every single device in the building. And obviously we can do some reporting and analytics around it, so that we can actually help you comply with building management regulations. So of course BMS is not really big in India yet. It's used in big buildings, but worldwide it's pretty big. They already have ready standards for it. And with IoT coming on board, now that entire industry is kind of getting overhauled. So typically where would you use something like this? Hotels like this, obviously, big conference spaces, universities. So the first project we did was for a university space, a pretty big campus. And we can also geolocate every light. So you can see them on a Google map and say I want to turn this off or I want to dim it. So that's pretty cool. So that's all where you would use this. So just to put this in, hi, welcome guys. So just to put this in perspective, what's this Joomla mobile and web company doing in a space like IoT? So basically the idea was that all the technologies we are using there are the things that we are already using right now. So it's all about HTML5, it's about REST APIs, and it's the same things that we are using to build web applications. So technology-wise, it's not really different. It's a very different space from an industry perspective. But technologically, we are doing the same things. So that's pretty cool. And I think that's the future. That's where things are moving. And we should be positioned for that. And that's why we are here. So that's where we have tied up with an American company. So Tech Ventures is a US partner for that. And they basically handle all the hardware side of things. And all the hardware prototyping is done by Tech Ventures, which is based out of California. They also handle a US office. And so TechD Technologies basically handles the entire software side of things. So the idea is that we are basically making hardware. So any electronic engineers in here? You are? So have you done embedded software development? Is it easy? It's not. So that was the whole idea behind this. What we want to do is that take the electronics, the development out of there and do it on the cloud. So imagine every electronic device exposing some APIs, just like any website, and you being able to match them up and do things with it using web technologies. So that's the core of this solution, and that's where we are coming from. So a little background there. So here what we did was that this was done for Autic lighting systems. That's based out of California again. And they were using they were using closed source hardware and closed source software, and we helped them replace their entire stack, hardware side and software side, with a completely open system. And it was built by Billion, if you have heard about them. So they do routers, if you know them, so we replaced that. So let's look at the challenges. So again, this building having tens and thousands and hundreds of thousands of devices, and imagine a systems or maintenance manager having to run around and having this, I don't know, team of maybe 30 or 40 people running around the entire building trying to find what the problem is. With this, you'll know exactly where the problem is, be able to fix it before it happens. So that's the whole idea. And I'll show you a diagram that will probably talk a little bit more. So this is what we actually ended up building. So what we have here is the gateway. So you know how a Wi-Fi router works? It's a bad example, but it'll come close to what we are doing here. So when you are connecting to a Wi-Fi router, you connect it to the system Wi-Fi, right? So right now the router knows who you are. Similar to that, what we built is a lighting router. So it's really a gateway. What it does on this side is that it will discover all the devices that are in the network. So we would probably set up one router for each floor, and it will be able to discover all the smart lighting devices. And what we have done on the device side is that, so Autic lighting, they are basically so just like the power adapter for this laptop, LED lighting and all, they need a driver. So basically the power supply, these guys manufacture the power supply. And what we have done, what we have done with that is that we have made the power supply itself smart. So the light tells us that, hey, I'm a light, and you can dim me from 0 to 10, or you can switch me on and off. Okay? So instead of the light, if you set up a motor, so the motor would say, hey, I'm a motor, my torque rating is from this to that, you can change my speed from this to that, and I obviously spin. So every device would declare what it is. So right now, it's been built to scale to any type of device. It's been only tested with lights, and it's actually in use for lights, but we have done some prototyping and it actually works with everything else as well. Do you have a question?
Sorry, can you just clarify?
Yeah.
Are these brand new devices you make, or can you adapt it?
You can adapt, you can adapt. So actually speaking, it's a power supply, right? So we could technically just put a special plug in between and put any device. But the only problem is that in that case, the control would be limited. It would probably be just on and off. because if we try and dim a motor, I don't know what would happen, because you'll probably get some funny things happening there. So for this is built for lights, and if I know that the device after that is a light, I could probably do something. But if I just do a smart adapter, it will just probably let you do smart on and off. But that's possible. You can retrofit, and that's definitely possible. So coming to the architecture. So where does Joomla come in? That's where it comes in. So imagine that you have those triangles up there. So you have all the types of devices. So imagine air conditioning, you have lighting, motors, whatever on that side. Now typically, what's cool about our system is that we can connect with devices over power line. Okay, and that's pretty cool. So you just plug the device into the power port, and we can communicate over the power line. And this was kind of shaky technology a few years back, but it's pretty cool now. And you can actually use it very, because with this kind of systems, you need to make sure that it's very robust. You can't say that I switched 100 lights on and they don't turn on. They have to turn on. And it has to be very real time. I can't say I turned it on now and then it'll switch on after 5 minutes. So you have to make sure it's very robust. So on this side, what we have made sure is that it's these are all the protocols we support. So Zigbee, if you heard about it, it's very popular in building management systems. That's like a protocol. We have JSON over power line. So basically, we made everything JSON. So you can say light 003, dim 35. So it will just set the level to 35. So probably I'm going a little fast here. How many of you guys have used web services or REST web services? Yeah. So you've seen what? Can you give me some examples of web services used? So let's say you are using a Joomla web service and you are telling Joomla, hey, give me all articles from category ID 35. And it would probably just dump all the data in a JSON object. So imagine here, instead of telling it to get articles, you are telling me, hey Joomla, give me all the lights in this room. So basically get all the lights. And now that you have the lights, and we'll tell you how to control. So we have some controls in the JSON command line script. So you can say on, off, or dim, or whatever. And the device itself is telling us what we can do with it. So tomorrow if the device says something else, and if we tell it that, that's fine. So that's where the abstraction comes in. Throughout the system, JSON is carried through. Now here, this is where actually the gateway Raspberry Pis come in. So I was actually trying to set up a demo here, but we were not able to get the devices here on time. So, but I'll just try and explain. So this is written in Python. It's all Raspberry Pi code. The main reason we used Raspberry Pis for the prototyping was that we could get all the networking on the device. And later on, we actually built our own boards. But we basically did all the prototyping on the Pis, and the actual working demo was built on Pis, and that's still active. So here we have a device subnet, which means that all the devices around that router are controlled by that. There is a local database where we kind of cache what devices are there. And then there is the controller. And the controller basically exposes the API here. So if you look at this, the resource ID is probably the ID of the device, what action you want it to do, and the value. So for example, I'd say DS3344 dim to 10. So imagine this light just dimming to 10. And now instead of doing this, if I have a group, I could just give those commands instead of the resource being a device. I can actually say group/group ID and give the action. So it will just escalate to the entire group. Now this is where Joomla comes in. So what we did is that now imagine you have a big building. You can't have just one of these control everything. So that is where we basically got another Raspberry Pi, or this could be really any computer in the network, where it actually gets all of these together. And now you have only one point to control the entire building. So we are aggregating everything using Joomla. And this is a typical LAMP stack, and the LCMS backend is built on the Joomla framework. So what we have done is that the same APIs, which are now probably Python on this side, are abstracted by this and exposed over the cloud. So I just have to give it an external connection, and then you have it being controlled over the cloud. So here, mainly Joomla framework has been used. So how many of you guys have used the framework, not the CMS? The Joomla framework? Anybody? Tried? Okay, cool. So it's pretty exciting what you can do with the framework. It's not supposed to replace any PHP framework, but it's supposed to work with other frameworks. And what we basically did was the REST APIs that we had built for the CMS, we just ported them to the framework. And we definitely did not want to use the entire CMS here because I'm not going to create articles. I'm not going to do anything on the web. I'm not even going to see the web front end. So I'm going to show you some screenshot of the actual front end, and it's built completely in HTML5. It's completely client side. So I could put it in a phone gap and package it as an application. Because on the back end, it's just web services. And probably, hopefully, if you guys attended the Joomla 4 session, web services are something that's definitely going to come even in the CMS and help us do quite a lot of things. So this is how the web services are used. This is the HTML5 browser UI, or you could have a mobile app. So let's look at the blue box. That's what we called it in the alpha stages, and that name has kind of stuck. We even actually changed the entire architecture, but we still call it the blue box. So this is being used as a cloud-based server that communicates with the various gateways. I have time, right?
Yeah,
Okay.
I'm just bringing in a few more people.
Thank you so much. So this is the thing that is going to expose all the gateways in the system to the cloud. Hi, Henry. Look at the green box. Now this is where the Raspberry Pi comes in. And what we have done here is that we have Python running on it to actually talk to the devices on the device side. How many of you guys have used the Raspberry Pi? So any examples of what you built with it? You used it, right?
Yeah, just run operating systems.
Okay, so you're using it as a desktop. Wow. Can you tell us about that? I know you do. You're not doing the session, but that's exciting to know.
So basically, using a Raspberry Pi, the network capability that it has, you can control the movements of a wheelchair. Okay, so basically it's a controller that
It's pretty cool. All right. So that's the Raspberry Pi for those who haven't seen it. It's actually this big. I was hoping I could at least get a Pi, but I just screwed up and didn't even get a Pi. But it's really small, and you can do a lot of things with it. So the latest models I think carry something like 1 gig of RAM, or is it more now? 1 gig of RAM, so you can practically run a lot of things on it. People have run entire Android applications on it. So the whole point is that because you have Pi and you can actually probably put the entire Nginx server in there, you have the power to do a lot of things. And I think a lot of you guys are web developers, right? So it's time to kind of expand your horizons here and start doing things, something that's more exciting, something that's beyond web, so to say. So what is cool about this again is that this can expand to any number of gateways, because you can't say that I can only control 5, because in a building like this you'll probably have 50, and they have to be auto discoverable. So it's basically so have you chatted on the internet in a group chat? Obviously you have, right? So now imagine a chat room where you have 50 lights. Okay, so actually that's how this works. It's actually a group chat, and the web service is being exposed, but actually it's a group chat. So I say, hi lights, all of you guys just dim. So I'm actually talking to the lights. So basically we used initially XMPP as one of the protocols because it had to be more real time. HTTP wasn't as fast enough, so we had to actually use XMPP. Later on we actually ported to something else completely, but that's how that works. So what happens in the framework? So we have used the Joomla framework, obviously. We have used the XM PHP package for the XMP stuff. Then obviously there is Bootstrap and Twig, and this is purely for the front end. Okay, this is not even, this doesn't need, this is not for web services. This is where the web services are signed. So APIs. So right now the framework app outputs two things. One is actually human consumable views, which is part of the HTML5 application. And then there are web services which can be used. So if I wanted to do mashups with this, so imagine you don't like my application, it has a sucky UI, and you want to build your own, you're completely free to do that. Because I'll expose web services to you, you can do whatever with it. So right now we are only using the web services here. So this is how the app looks. So this is the home screen. You can do scheduling, you can do grouping, you can do user management. So now again a question here, why did we actually use user management? This is not CMS user management. This was a layer that we built on top of the framework because the kind of ACL we needed was not how it is in the CMS, and the overhead of the entire CMS wasn't worth it. So that's why we used our own user management system. So this is manufacturers. So all the manufacturers that are auto-discovered across devices will be listed here. the actual devices itself, so that you can start playing with it. Now this is the cool part. Let's say you install smart devices in a building. Are you going to actually enter 10,000 devices into the system? You don't want to do that, right? So that's why polling and auto discovery helps. So once you actually just ask them to, there is a discover button here. You just click it, and it will start polling for devices, and the devices will start, declaring themselves, and we get the entire device tree right here. So it will also discover the services. So like you guys said, some of you have used web services, and if you have seen web service documentation, especially SOAP ones, JSON typically I haven't seen them do really good documentation, but if you've used SOAP web services, you'll actually be able to see the entire tree and the actions, and the entire discovery can happen. So basically it can declare that I'm a light or a motor and all that. So it's actually declaring the services. In case of lights, that's on, off, dim, and depending on the device, that can change. So now let's say you want to group. So as I said, you could group devices together and do things with the groups instead of having to control each device individually. In fact, this is what is actually used, because you're not going to control one device when you have tens and thousands of them. You'll probably always control them in groups, and this is what can help. And you can actually put the device in multiple groups and then do stuff with it. Then you can obviously do scheduling. So we already talked about that. And you can actually override each device. Override rings some bells. You do overrides in Joomla, right? Template overrides and whatever. So of course this is not a template override, but basically you can say that this is coming from the group, but still I want this specific device to work differently. So I can configure that device to say that this is special, and don't act like the group acts. Act something simple. As I said, mapping. So you can actually just see all the devices on a map. Like they show in the movies, that all these hackers hack into these systems and then turn off the signal lights and everything. You can do that, but this is really secure. Hopefully you won't be able to hack into it. And only if you have access you can do that. Then the user management, obviously, so you can manage users. Very simple user management system, basic grouping. And then this is the best part, that I think you asked a question, that what if I'm not controlling all the devices? What if there are third-party devices? This is exactly why we have multiple transport mechanisms on the end user side. So we support such a big array of connectivity options that it doesn't matter what you're using. But practically we are actually in the live situations, we are only using power line, because that's zero effort, because I don't have to do any additional wiring. The actual smart device doesn't have to have Wi-Fi, Bluetooth, anything. So just to give you how Powerline works, a very, very simple explanation. Again, I'm not an electronics engineer, so don't ask me questions about that. But you have seen how AC works, right? It's a sine wave, right? So how Powerline communication works is that it's going to work on a very different frequency. I'm not sure if you have a whiteboard, but I'll just try and draw on that. So if this is your sine wave, imagine a very low frequency communication happening over the same line. And you have on both the device end and on the end, there is basically a receiver and a transmitter, which can actually take this coded low frequency signal. So you don't need additional wiring. That's what it helps basically. So XMPP and COPE, these are two protocols that we use. So as I said, manufacturer management, asset management, that's the simplest and the easiest part of it. People are already doing that. We just simplify it for them. This is the before and after. Do you recognize this logo? Billion. If you have ever configured a router, they do the embedded systems for quite a few routers. So this is what the old system was. This is the new system in HTML5, Bootstrap as we love it. And now it's completely web-based. This is the look at the prototype, because I couldn't actually get it. So this, all that is the mess that we made, and it actually worked. And here you are actually seeing that. So that's the prototype. So while doing this, and this is one of the things that we are doing at our company, is that we have made open source contributions a strategic thing. And we basically make sure that some contribution happens with every project we deliver. So when we get a new project, we say that, what can we give back out of this? And we say that we are going to do that as part of the deliverable. So open source contributions are not optional anymore for us. We have to do it. And I don't know if you have any Joomla people in there, but they have like KPIs that go towards the salary and stuff. So they have to do it. So that's fun. So basically that helps us make it central. Otherwise it ends up, we made this code and it got lost somewhere. It never actually, got reused. And if you guys have software companies, you know that you want to reuse as much code as possible. You don't want to let that great piece of code go somewhere. So whatever you develop, just release it on GitHub. If you can't contribute it actually to CMS or the framework, just release it on GitHub. Maybe somebody will find it useful, fork it, make something out of it. So this is what we did for the framework. So we did a full CRUD example for the framework web services where you could do add, edit, list with web services. And we also did a router that simplifies the RESTful URLs. So Joomla 3.5 is coming with a router, but that's the CMS router. So you remember the URLs? So we wanted the URLs to be simple and friendly. So URL/group/action/that. So we had to write a router to make that happen. So what else is going to happen around this? So obviously everything around IoT. LCMS is just one small case of what you could do with this. And there are so many applications you can do. So just as an example, I have a full drip irrigation system on my rooftop running on a Raspberry Pi. It doesn't use Joomla, but it's basically, I can just make sure my plants are watered from here. And it's again Raspberry Pi. And I could have used the Joomla framework to do that, but I didn't because I wanted to try something else. But you could actually use the same framework to actually control that as well. So M2M and M2E communications, that's going to be the next step, because right now we don't have machines communicating with each other enough. And as more devices go online, you will want to make it easy for them to communicate with each other. And all those wonderful test cases that you heard, that the milk got over, the refrigerator orders milk, all that is cool, but we'll probably see some more practical things happening right now, which actually help and are not just great. So that's what seems to be, that's something that will happen. So this is just a quick term glossary in case some of you are not technical. So API, I'm assuming you know, which is application programming interface. LCMS here is lighting control management system. We have XMPP, which is extensible messaging protocol. So typically Google Chat and all these guys, they use XMPP. Of course, Google has rewritten the whole thing, but basically it's like XMPP. RPI is the Raspberry Pi, and COPE is basically it's similar to XMPP, but mainly it's specifically a fork, so to say, that's specifically written for electronic devices. So that's it on my end, and I think we'll just have some discussion and questions. So questions or ideas or whatever?
Does the communication with power lines work?
It's pretty, actually we haven't tried it yet. Because, but I think we are pretty confident it should not be a problem. But there are, the line disturbance in India is pretty high. So, our prototypes that we have in the office work, but then when there is so much around it that's really keeping the line safe. But the noise over the lines in India is pretty large. I'm guessing that these guys have some kind of purifiers at the core, so it should probably be good. Any other questions? Ideas? What else?
I missed it earlier. Do you have source code or that you are building?
Actually, this is not, because it was built specifically for companies, so we haven't been able to open source the whole thing. But whatever we built for the framework, we did open source that. So there was a layer that was kind of proprietary that we had to keep specific to them. But everything that we were able to open source while building it, we open source that. But what you can try and use is that if you want to do something similar, you can try using wiring pi. And you should be able to do something very similar like this. It will be a little constrained, but I'm assuming you won't need power line communication and things like that. So, yes, sir.
I didn't understand very well. You can interface this with the Joomla administrator?
Not the Joomla administrator. So what we used here was the Joomla framework, not the Joomla CMS. So what we did was we used the framework to write web services, and then we built a custom HTML5 front end for it. And it's not really using the Joomla CMS at all. But practically you can do it, because all you have to do is write a component that uses those web services.
Yeah. And the GitHub to run put the slide for the GitHub project.
Oh, yeah, sure. Yeah. So that's github.com/coolbung/frame. So Coolbung is our CTO. Is he here? He's not. That's his funny handle. So you can just note this URL down. So and actually, if you actually check our, you can also check github.com/techjoomla. So we did some exercises around the Joomla framework in the company, some code sprints, and we got some really interesting applications done on the framework. So there's a photo gallery application, there is also a small URL shortener application, and some fun things with the framework. So if you want to check that out and poke them and do some nice things with it, you're more than welcome. I'm going to take a photo. Or whatever. So, should we close? I'm done. So, thanks a lot. Thank you everybody for attending. Thanks. So, what other sessions are you guys planning on attending next?